So what's the velocity of a helium atom that is a temperature of 6,000 Kelvin? So when you get this problem, what you do is you ask yourself, what are the two things I have? So what is the velocity? So that tells me this, 1/2 mv squared. It said velocity, so I need velocity. That has a temperature of 6,000 Kelvin. Okay, so it talked about velocity, it talked about temperature, it did not talk about kinetic energy. So this is what I do on this problem. I cross out kinetic energy, and I solve this. 1/2 mv squared equals 3/2 kT. So 1/2 times 6.64 times 10 to the negative 27th times the velocity, which I'm solving for, squared, equals 3/2 times k, 1.38 times 10 to the negative 23rd, t, which is 6,000. So then you just do the math. And the math is easier said than done because this is scientific notation. So I'm going to multiply these three things together first. So 3/2 times 1.38. My calculator uses this button times 10x. That's how I do the exponent. Then I do negative 23 times 6,000. Okay? Gives me this number, 1.242 times 10 to the negative 19th. Okay? And then I just divide the other numbers over. Good job, man. Yep. Oh, good, I got it back. Okay. So I'm going to divide both sides by 1/2. Divide the 1/2 over. And then I'm going to divide the 6.64 times 10 to the negative 27th. So divided by 6.64 times 10 to the negative 27th. And I get this enormous number. V squared equals 374,09638.55. Square root both sides. V equals square root of that. 6,116.3 meters per second. Just pretty fast. But it should be. It's the sun. So, should be pretty fast. All right? I'm going to come around and see what questions you have. You should work on finishing 4, 5, 6, and if you have not done so already, 1 and 2. If you have not done so already, 1 and 2. Just do some calculation conversions. And then 4, 5, and 6. Let me come around and see how you guys are doing on that. And then we'll see where we are. Did you guys have any questions about anything? You could say, so a slightly more thorough answer would be to say it approaches 2.
As the temperature reaches up to 0, it's losing 1 light.
It decreases, it's fine. It's more thorough to say it approaches 0. Yes, it decreases. So as you approach basic idea is the temperature of an object is proportional to how much kinetic energy it has. And so therefore, as you decrease your kinetic energy, you increase your temperature. As you decrease your
I want to show you what
try. Not all the time. Frequently. Okay, do you guys have those two things? Oh, flavor two things are like a great adventure.
I tried to make my own, it didn't work out. This is a waterfall shack. Wrong number. Wrong.
If you want
I got
here.
So if you want to I want to know you guys can go ahead and grab a seat. Go back to your seats. So next time we'll finish going over the practice, and we'll go over that. We'll go over the notes for heat transfer. Last week was a weird week. It was a weird week. Yeah, and all the band people were out. It was a weird week.
You weren't here.
Huh?
You weren't here.
I know. Well, right. I was here, but I was helping Mr. Orbeck. I was here, but it was an e-learning day. I was here, but we had that massive fire thing. Like, yeah, it was just a weird week.
What an awful. I feel like if the whole school. Come on, Kurt. Let's get out of here. Let's go talk to the
See y'all.
Do you know when you're going to do the board?
I'm trying to get him this one. So, yes, my goal is to get him in for this.
My grade is going well.
You're literally down to the station.
I know, it was embarrassing. Hey, don't do that.
Yeah, don't break my clock. I just got it fixed. It does work. Not only is the second ticking one a second at a time, but it's the correct hour. I know. It is an actual fully functioning clock. I have not had one of those in many, many a moon.